Hey there everyone, I thought I'll make you a new video showing you just some, or actually giving you a video memorandum of the control test in this one, and thought I will start by just showing you a little bit of this document that I sent you a while ago. This document gives you the math skills you should be able to do in your exams, and to specifically in control test 2 we did a calculus, and so here's just a few skills that I should be able to do in calculus. Level 1, I should be able to find the limit with straightforward substitution. So in other words, I have to find the limit and I can substitute, find the average gradient between 2 points on a function, find the derivative of a function using limits. Okay, and this is a level 1 skill. It is basically a level 2 skill as well, a routine procedure, and so you'll see that it can fall in either level 1 or level 2. But if we go to the control test, that's exactly what we see in the first step. This is a very straightforward finding the derivative from first principles. So if I go to that, fx is equal to x squared, most of you should be able to do that. But from first principles basically just means I'm going to start with fx is equal to the limit of h tending to 0 of fx plus h minus fx. So just starting with this formula already gets you 1 point. Okay, and then the next point goes for substituting. So what this means is that everywhere where there's an x in my original function, so fx is equal to x squared, so everywhere where there's an x, I'm going to replace an x plus h, whichever is in there, which means f x plus h means instead of an x, I have x plus h. But just a safe thing to always do is when you substitute with a bracket so that you can include all of the other operations over the whole thing. And so when we do that, we therefore have that as the limit tends there, we now have just x plus h squared minus x squared over h. And now it's basically just getting to a point where I may substitute the 0. I can't substitute now because then I'll have 0 in the denominator, but basically this would be our second point. Our next point is going to go for towards actually getting a value that is where I can substitute because there's no more h in the denominator. So usually that would be because my h in the numerator cancels, but I can't yet cancel because I don't have common factors. So multiplying that out, I get x squared plus 2xh plus h squared minus x squared. And you'll see what should happen almost all of the times is that your terms that doesn't have an h should cancel, so that now you have common factors. You can take out a common factor and cancel it with the h. Let me rather not skip steps, and then I have an h taking it out plus, well, I suppose I don't need the plus, 2x plus h is what's left divided by h. These cancel, and now I can just write my final step, which is substituting the h. You see I got rid of the h, so once I substitute the 0, and the moment I substitute the 0 I stop writing limit. So then I've got 2x plus 0, and so there's my derivative from first principles. Okay, and that is finding the derivative from first principles. So if we go back to the skills, finding the derivative, of the following from first principles. That is this one that we did, ax squared plus bx plus c. We just had a very simple one with just x squared, and it was very simple by just following those steps, and you'll see you already then have 4 points. Okay, find the average gradient between 2 points on a function. Okay, find the instantaneous gradients using first principles. Finding the derivative of a polynomial function may require simplification. Okay, I do want to not go over all of this, but each of these skills can be asked. I want to go to this one. Find the derivative of an expression with radical or fractional exponents, and that's exactly what we have in our next question. We have to find this derivative. Is they say if y is equal to that, find or determine dy over dx. So in this expression, we're not allowed to just take the derivative of the numerator divided by the derivative of the denominator. There is a special rule that we learn later on in varsity, but for now we're just going to say y is equal to, what is it, 3x squared plus 2. Okay, and now in order to be able to find the derivative of this expression, we must get it in the form we simply have terms. So something plus something plus something, where each of those terms has a coefficient, an x, and an exponent. Okay, plus a coefficient, an x, and another exponent. Okay, so that is the form that we have to get before we can find the derivative. Now what usually means is that we have to distribute the denominator. So we're going to distribute the denominator, and then we're going to use exponential laws in order to simplify it into this format. So we've got 3x squared divided by, and now what just makes sense is to write this radical with fractional exponents. So square root means divide by 2. So this is x 3 over 2, and then plus 2, and then square root x is x to the power of a half divided by x to the power of 3 over 2 plus 1 over x to the power of 3 over 2. Okay, and so now I just continue to subtract the exponents because I'm dividing common bases. Then I subtract exponents. 3 over 2 is 1.5. So this becomes 3x. 2 minus 1.5 is a half. Plus 2. A half minus 1.5 is minus 1. Plus 1. And then let me just see if I wrote it all. That should be a negative. Okay. Negative. Okay, and then this one becomes 1x. This has an x to the power of 0, so 0 minus 3 over 2 is 3 over 2 with a negative. Okay, and now once I get into this format, now I can take the derivative. Hopefully you know that in order to take the derivative, we take the exponent, multiply it to the front, and then subtract 1 from the exponent. So 3 times a half is 3 and divided by 2. X a half minus 1 is negative a half. This time negative 1 times 2 is negative 2. X minus 1 is minus 2. And then finally this negative times negative is positive 3 over 2. X minus 1.5 minus 1 is minus 2.5, or x minus 5 over 2. And there's the final answer. So the way that marks were allocated here was 1 mark was allocated for getting it into this format, and from this format, for every term that you correctly found the derivative of 1 more mark was allocated. Okay, let's do the next question. Okay. The next question then says, consider the cubic polynomial. There's the cubic polynomial. And then they ask you to find the coordinates where f intersects the x-axis. Okay, and I want you to show something. Notice they ask you to find the coordinates. Coordinates means it's an x and a y value where f intersects the x-axis. Okay, and whenever we find any coordinates for intersection, let me clean this. Okay, coordinates intersecting the x-axis, we have to make, let's choose a color here, we have to make our y value equal to 0. Okay, confirm that. 2x minus, yes. Okay, so to get my x coordinates, I make my y value, which is this, equal to 0. So I'm going to just make this equal to 0. And then I saw almost everybody went and simplified this expression, which is ridiculous, because the way you solve any polynomial expression, something that will end up being like ax squared or ax to the cubed, which this one will be, is you factorize. And this thing is already factorized. So it was basically just noticing that x minus 1 squared is going to be 0, or x plus 1 is going to be 0. And this just means, well, take the square root on both sides, plus minus on the right hand side will be plus minus 0. So it's just going to stay the same. So x is going to be 1, or x is going to be negative 1. And so they asked me for the coordinates, so I had to put 1 for x and 0 for y, and negative 1 for x and 0 for y. So stupidly simple. So you got a mark for making it equal to 0, and then for each correct coordinate. Okay, then we said find the coordinates of the turning point of this expression. Now, if in the first step you then simplified this expression to get the turning point, and then factorized and got the same answers, then at least you would have now had the simplified expression. But in order to find the derivative, the turning points of a function like this, which looks something like that, the turning points of any function actually is where the derivative is 0, where the gradient is 0. The derivative is a formula for the gradient. So I want the points where the gradient is 0. So I'm going to take the derivative and make it equal to 0. Now the derivative of this function, I'll first have to simplify that function. So let's do that first. So I get 2. First I'm just going to multiply these two with one another. So I'm going to keep one of the negative ones and multiply it with the x plus 1. The reason why I do that is because then it's the difference of two squares. So it's x squared minus 1. Okay, so x plus 1, x minus 1. But then there's another x minus 1 left. And so now I just do multiplication of this. So now it's x cubed. Then there's minus x squared minus x. And then finally plus 1. Cool. And that gives me 2x cubed minus 2x squared minus 2x plus 2. Finding the derivative of that is then super simple. Just multiplying the exponents. So that's 6x subtract 1 is 2 minus 4x subtract 1 is 1 minus 2. And this must be made equal to 0, which then simplifies this expression into 3x squared minus 2x minus 1 is equal to 0 into 2 brackets equal to 0. And then this one can only be a 3x, and this one can be a 1, this one can be an x, and also has to be a 1. Now it's just trying to figure out which one gets the positive and which one gets the negative. So I must get negative 2. So obviously when I multiply this and add that, I must get a negative 2. So the negative 3 is the larger one, so this must be positive. So -3 positive 1 gives me -2. And this then leads me to two answers. It gives me x is equal to -1/3 or x is equal to +1. Again, if I go and read the question, says find the coordinates of the turning point. So I must find the y values as well. Okay, so now I go ahead, find the y values. Okay, y values will be at f1. Now I already know what f1 is. f1 is equal to 0. When x is equal to 1, y is equal to 0. I already know that. Okay, so in other words, this coordinate is 1, 0, and I could have actually figured it out from the beginning because there's two intercepts. There's an x minus 1 and there's another x minus 1, which means that this graph, when it turns, okay, at 1, this is going to be at 1, it has a root when it comes down on 1, and it's going to root when it comes up at 1. So it's got a turning point at that point. Okay, so that's the one turning point. The other turning point is at -1/3. Now, -1/3, I then substitute in here. 1/3 in there gives me 2 times 1/8. No, 1/27. 2 times 1/27 minus 1/, and then it's minus 1/9 minus 1/3 plus 1, and then if I add all of that together, I get, so all of it must be over 27, so I'm going to make this a 3 times 3, this a 27 times, no, a 9 times 9, and this last one a 27/27. So I get 20, first I get a 1 minus 3 minus 9, and the last one is plus 27. So it's 27 minus 9 is 18, minus 3 is 15, minus plus 1 is 16, times 2 is 32/27. Now I'm a little bit unsure of that answer. It doesn't feel right, but so I'm just going to test it in here. Notice how easy it is when I substitute it in there. So if I did substitute it in here, I would get that this is, and the reason why I think my answer is wrong is because I didn't substitute negative. Yeah, there must be a negative. Okay, and this one is squared, so that one is, and that one will be positive. Okay, cool. Now it seems a bit more right, but okay, let me in any way show you how nicely it works out if I substitute in here. So if I substituted in here, I would get negative, and this would be a 3/3, so minus 3/3, so I get -4/9. So it's -4, not over 9, over 3, and then that gets squared, and that gets multiplied with positive 4/3. You see, positive 4/3. Okay, and this one is squared, so that is 16/9 times 4/3, which gives me 16/9 times 4/3 is 64/27. Cool, and I do remember the memo, and that's why I thought this is odd. That is 64. 64/27. Okay, so there we go. There's my 64/27. Obviously most of you are using a calculator anyways, so those that got to this point did get it correct. And then let's quickly look at the last question here. Sketch the graph of fx and clearly indicate the coordinates and all the intercepts and turning points. So if I am going to sketch the graph of this, I don't need much more space than that. So there's my coordinate system, Cartesian plane, and then I'm just going to put in my important points. So I know I've got a turning point on here. I've got, let's say that's 1, 2, 3, 4, 1, 2, 3, 4. This is roughly, see, 27, 64 over 27 goes about 2 times in there, then it's 54, so 2 and a little bit, so I'll have to go up about 2 units, but let's make, especially since I'm working in thirds, so let's make this 1, and that one 1, and then this one 1, and there's 2. Okay, and yeah, so my first point, or my 2 turning points, are 1, or x-intercept is I've got an x-intercept at this point and at that point, so at -1. This one I know is also a turning point, so I'm going to have a turning point here at x equal to 1, and then I have another turning point at x -1/3, and -1/3 is somewhere here, 2 point something, where it turns, and then I'm cutting the x-axis again at that point. Okay, I also, or what you should know, is that if I'm working with a cubic function, which is what we have here, this is a cubic function, it simplifies into an x cubed. A cubic function has this n shape, or it has this upside down n shaped. Now if the coefficient, the leading coefficient is positive, then it's this normal n shape. So this is the normal n shape, and it just has to have a turning point. What is going on? Okay, it has to have a turning point here, going down, and then one there going up. And then one more thing that I can look at is where it cuts the x-axis, and we'll cut the x-axis after I simplify it, the y-axis. When x is equal to 0, it's going to cut at 2. So I could look at that as well. So it's going to cut here at about 2, and then I just draw my shape through those points. Through there, down here, turning there, going up. Okay, and let's see how many marks that was, awarding 4 marks. This previous one was 6 marks, so let me show you how those 6 marks were awarded, okay, for finding the turning point. So first of all, you got a mark for simplifying it into the simplified form. Then you got a mark for finding the derivative, making the derivative equal to 0, then finding 2 answers, in other words, finding both of those 2 answers, and then the one coordinate turning point, and then the other coordinate, which I didn't write, and I would have lost the mark. Oh no, I did write it. Here it is. Okay, there's the other mark. See, 1, 2, 3, 4, 5, 6. 6 marks. Now, for this one, I think it was 4. Yeah. So 4 is for 1 for the shape, 1 for the shape, 1 for each of those coordinates, 1 for the other turning point. So up here, the other turning point. And so 1, 2, 3, 4. There we go. Excellent. Well, thank you. I'm going to maybe let's just do this last one. It's getting to be a bit of a long video, but let me just do this last questions. This says, for the opening promotion, an online subscription service charges 50 Rand per month to watch unlimited movies and series for a month, like Netflix. At this price, they are selling 1,000 subscriptions per month. But market research suggests that for every 5 Rand increase, they will sell 20 less subscriptions per month. So as the price go up, they sell less of their subscription service. If X is the number of subscriptions sold and Y is the price per subscription, then it can be shown that X, the number of subscriptions sold, is equal to 1,200 minus 4Y. The total sales per month for selling X subscription each month is, there's the total sales. Now they ask you, what price should the subscription service charge to earn maximum sales? So here's the total sales. We want to maximize total sales. So we want a maximum value. And if we look at any sort of graph, a maximum is there where it turns. That would be this value that I read off here. That would be what we call a local maximum. And that's exactly what we're asking. So let's make some space again. So here is our expression, px. So if we want a maximum, my point being, if I want the maximum for that expression, all I'm looking for is the turning point. It's a parabola, so you could have used different methods to find the turning point. The simplest method is just make the derivative equal to 0. The derivative is a formula for the gradient. So if I have my expression minus 0,25x squared. So there's my expression. If I take its derivative, which is 300x minus and then 0,5x, sorry, this is not 300x, it's just, and I make my derivative equal to 0, then I can solve it and I'll get that x is equal to 600. So what is equal to 600? Well, let's go and see. X represented the number of subscriptions sold. And they tell us what should the price of the subscription service be. What price should the subscription service charge to earn maximum sales? And in order to get maximum sales, x has to be 600. Okay, now x is the number of subscription sold. I want y. So 600 is equal to, and now I get 1,200 minus 4y. And if I solve y, then I get 4y is equal to 600, 1,200 minus that, and then 600 divided by 4 is 150. In other words, they should charge 150 Rand. Cool. And that was it. Well, hopefully, I don't know if this was helpful. I do hope for your sake it was. And as you can see, even with explanations, it took this video about 27 minutes and you had 30 minutes to do it. So good luck, and I hope if you have any questions you'll ask.